In the first part of this tutorial, I showed you how to create a new format to replace a basic format, and then define a specific mapping between that format and another format. In that example, I created a 5120 by 2160 format and mapped it into the HD 1920 by 1080 format so that it filled the height of the screen. I will now show you how to create a different mapping where I want a certain area of the input shot to fit into the width of the working format. In this example, I have a frame and focus chart which has been shot with a spherical lens and recorded at a resolution of 4096 by 2160. The final deliverable will be shown on a screen with an aspect ratio of 2.4 to 1. And the shot has been framed so that there is some space around the intended final frame. This may have been done to avoid vignetting caused by a lens, or perhaps to position the boom mic so it's just out of shot. I want to map the 2.40 area, shown on this chart, into my working format. This type of mapping is sometimes called a center extraction. The input format is currently set to DCI 4096 by 2160, which is a factory format and was automatically applied to this shot on import because it matches the shot's resolution. However, I'm now going to create a new format for this special mapping. I'll start off by opening the Formats editor. And now I'll click on the New Format button. Again, I'll create this format for use just within this scene. And I'll now enter a name for the new format. I'll call it 4K 2.40 into HD. And I'll set the width and height of the image to the resolution of the input media. That's 4096 by 2160. It has square pixels, so the pixel aspect ratio is 1.0. Now I need to create a mapping from this format to the HD 1920 by 1080 format. However, unlike the last example, I need to specify a certain area within the source to map into the width of the destination. Some cameras allow you to set up custom reference lines or grids in the viewfinder, so it may be possible to get the pixel values from those. Some monitors or external scopes also provide pixel measurement cursors. However, pixel coordinates can also be easily measured in Baselight using the crosshairs in the image display. I'll just close the Formats editor window for now so you can see this more clearly. First, I need to make sure that I'm viewing the image at its original source resolution and not the scene's working resolution. As I mentioned earlier, the viewing format of the current cursor is normally set to match the scene's working format. However, in this case, we want to set the viewing format to match the shot's input format. If I click on the Viewing Format button in the cursor's view, I can now choose the new format I just created. Now I can click in the main image display to get the pixel values for the area I want to map. I'll toggle over to the image display so you can see this more clearly. If you have a separate image monitor, then you'll need to move the mouse pointer over to that display. First, I'll click on the top left-hand corner to get its coordinates. Now, as the chart isn't quite square, I'll click just outside the 2.40 area, and that looks like it's at 397 and 389. And now I'll click in the bottom right-hand corner, and that's 3698 and 1765. So I'll note those values down and go back to the Formats editor. Now, in order to specify the source area for the mapping, I first need to define it as a new mask. So I'll select the Masks tab. Now I'll click on the New Mask button and give it a name. I'll call it 2.40 Frame and Focus. Now I need to enter the pixel values I noted down earlier. First, the top left corner was at 397 and 389. I need to make sure that the top-down coordinates mode is selected, as this is the way they are displayed by the crosshairs in the image display. Now I'll enter the bottom right corner. That was 3698 and 1765. You can now see that we have a mask within the overall frame, which defines the 2.40 area we want to map. Now I need to create the mapping into the scene's working format, so I'll switch over to the Mappings tab and add a new mapping. I'll choose the HD 1920 by 1080 format and click Add. And now for the magic. In the source, rather than mapping the full area, I'll choose the 2.40 frame and focus mask I just created. And in the destination, I'll choose Inside. This has automatically calculated the scale and translation values to map the width of the 2.40 frame and focus area into the width of the working format. It's also possible to map a source mask into a destination mask, but in this case I want to map into the full area. Okay, that's done. So I'll close the Formats window and switch back to the HD 1920 by 1080 viewing format. Now when I set the input format of this shot to 4K 2.4 into HD, you'll see that the 2.40 area now fits perfectly into the width of the image display. One thing you'll notice though is that the height has not been cropped, and although the scaling and position are correct, we can still see the image where it's outside the intended deliverable frame. This is because a format mapping simply scales and shifts the image. If we want to mask off certain parts of the image, then this can be done using the mask option on the current viewing cursor. We're currently viewing at HD 1920 by 1080, so we can enable any of the masks which have been defined in that format. The Masks button may not be visible in the cursor's view by default, in which case you can add it from the Add Options drop-down. This format has a lot of masks already defined, as it was copied from a factory format. But if you didn't have the one you wanted to use, you could always create a new mask in the Formats editor in the same way that I just created the mask in the 4K format. Okay, so I'll choose the 2.4:1 mask from the list. Okay, now we can only see the intended deliverable area of the source image. Note that the mask is simply applied as an overlay on the image display, so we can choose to make it semi-transparent if we want to check what is being cropped out. We can also apply the mask as a guide. Note that if you want to have the mask baked into the render, for example to make a letterbox deliverable, then you will need to enable it in the render settings too. So far, we have only considered mappings between the input formats and the working format of the scene. However, we may also need to define mappings between the scene's working format and the output format of the deliverable. For example, I am working at a resolution of 1920 by 1080 using an HD monitor. But let's say the final movie will be shown on a screen with an aspect ratio of 2.40:1. I can preview the area which will be visible by adding the 2.40 mask to my cursor. But the deliverable may need to be rendered out as a DCP with a resolution of 2048 by 858. So a format mapping will need to be applied between the 1920 by 1080 working format and the 2048 by 858 DCP format. If I open the Formats editor again and show you the factory formats, you will see that there is already one called DCI 2048 by 858. In the mapping section, there are no mappings defined, so if we choose to render to this format, a basic mapping will be automatically applied. In our case, this will be fine, as it will ensure that the width of the working format will fit exactly into the width of the deliverable, and the top and the bottom of the working format will simply be cropped off evenly. However, we may want to specify a custom mapping. I could create a new custom format for the 2048 by 858 deliverable and define a mapping in that. But in this case, I'm going to modify the existing DCI 2048 by 858 format. Now, as this is a factory format, I first need to copy it into the scene so it can be used. This is done using the Use in Scene Copy from Factory option here. This icon shows that the format is now included as a scene format. Note that the scene icon is currently grey. This tells me that the settings are currently the same as its parent format. I'll explain more about that later. Okay, now I'll add a new mapping. I want to map between the scene's working format of HD 1920 by 1080 and this format, so I'll choose HD 1920 by 1080 from this list. You can now see how the 2048 by 858 deliverable will be created from the 1920 by 1080 frame. Now, as I'm actually creating a mapping from the 1920 by 1080 working format to the 2048 by 858 render format, I'm going to switch back to the HD 1920 by 1080 format again. You'll notice that this now has a mapping to the DCI 2048 by 858 format, although it says reverse, as we created the mapping from the destination format. Now, for the sake of this example, I'm going to move the source image up a little bit. This may be required to allow some space for subtitles, for example, although bear in mind that the top of the image will be cropped a little more. Okay, the HD frame is now shifted up slightly relative to the output frame. Note that I can also make this adjustment interactively if I switch the viewing format to DCI 2048 by 858. Notice that there's a small film strip icon next to the format in the drop-down on the cursor's view. This is telling me that the mapping is customized between this format and the scene's working format, rather than using the normal basic mapping. I can now adjust the Y translation in the Formats editor and see the effect that it has on the output image. So this is what the final deliverable will look like when rendered to the DCI 2048 by 858 format. While I'm working on the scene normally, I can leave the viewing format set to HD 1920 by 1080. But at any point I can check what the final render will look like by switching the viewing format to DCI 2048 by 858. Now you may be thinking to yourself, hang on a minute, if the input is being scaled down from 4K to HD and then back up again to 2K for the deliverable, aren't we going to lose some quality? Well, not necessarily. Internally, the system will try and keep the quality as high as possible. So if two transforms are needed to produce the final output, it will try and combine them into a single transform. In this case, rather than applying the mapping from 4K 2.40 to HD 1920 by 1080, and then a second mapping from HD 1920 by 1080 to 2048 by 858, it will work out the overall mapping from the 4K format to the DCI 2048 by 858 format, and it will apply that as a single transform. There are, however, some situations where multiple transforms will be applied. For example, if you've enabled the input cache on a shot, then the cached frames will be generated at the scene's working resolution. In this example, that would mean that the input cache has a resolution of 1920 by 1080. The system will normally try and speed up rendering by using frames from the cache if they're available. However, this may mean that a second format mapping will be applied to convert from the cached frames to the output format. To avoid this happening, there's an option in the render settings to disable the cache. This will ensure that the original input resolution is used. However, it may take longer to render as the cached frames will no longer be used. There are other situations where multiple formats may be applied. Certain types of operator may bake in a transform, for example. Full details can be found in the user reference documentation. In the next part of this tutorial, I will explain how formats can be used in multiple scenes and shared with other jobs, or made accessible to other Baselight or Daylight systems.